So for us, there are three kinds of equalities where really only one of them is particularly interesting. The first is what's called an identity, and an identity is an equation that's always true. So there are more useful versions of identities, and often the most worthwhile question with them is whether or not they are actually accurate in the way we suspect. If it's a very obvious one, it's not very useful, but sometimes they are very clear. And for us, a simple one would be something like that 2 times 4x is equal to 8x. This is definitely always true because algebra kind of depends on things like that happening. On the other hand, we have things that are called inconsistent equations, which are ones that can't be true. So this might be something more like 2 times 4x is equal to 6x. If that was the case, then we'd be operating under a very different number system, and a whole lot of other things would have to change. Since inconsistent, it's something that can't happen, at least under our assumptions of reality, because otherwise, well, it'd cause a whole lot of chaos. It'd be a lot like dividing by 0. We don't want to do that. And then finally, the third case is the one that we spend the most time with. It's the one that's the most useful for us, because it's the one that has the most that we can study with our algebraic techniques, and that's a conditional equation, which is something that can, in certain circumstances, be true. So all of our examples, except for, well, these, are conditionals, because those are statements, equations, that are true for certain specific values of x. And next we're going to look at an example for classifying something in this way. So we want to solve and classify the equation 3 over the quantity x plus 6 plus 1 over the quantity x minus 2 equals 4 over the quantity x squared plus 4x minus 12. Okay, so this has a bit more work to it, but it is the same flavor of thing that we saw when we were talking about rational equations, except now we've got a square in there. And in particular, that thing on the right side, or that thing on the, that would be the right-hand side, left and right, stage left, your left, would be what's called a quadratic in the denominator. It is a square term. We haven't talked about quadratics yet. We'll get to that later. Hopefully you still do have some memory of that from elsewhere, though. But for our purposes, we want to find a least common multiple that we can deal with, and that quadratic as it is kind of a monkey wrench. What we could do if we really, really wanted to is be very inefficient, and for our least common multiple, take x plus 6, x minus 2, and the quadratic, and multiply everything by everything, and be left with a real mess on top. But because I'm not in the mood for that, and because I'm being a little bit nicer, hopefully those of you who are familiar with or remember dealing with factoring will notice that x squared plus 4x minus 12 actually factors into x plus 6 and x minus 2. And make sure if you can't remember how to do that, think about what it would take to multiply to get negative 12. Negative 12 can either come from plus or minus 4 times the opposite with 3, plus or minus 12 times the opposite with 1, or plus or minus 6 with the opposite 2, where if you take 6 minus 2, you will get 4. So as a result, we have that our factors for that are 2 and negative 6, but don't worry too much about knowing that process yet. We'll get there. The point is that our mess there has a slightly friendlier version as 3 over x plus 6 plus 1 over x minus 2 is equal to 4 over the product of those two linear denominators, which doesn't seem great, but it actually makes our idea with the least common multiple a lot nicer, because the LCM for these three is just going to be that. And as a result, we can multiply the whole thing by x plus 6 over x minus 2. X plus 6 times x minus 2, excuse me. Not going to be very pretty, but sometimes they aren't. really remember that these things, they're kind of just acting like constants with a little bit more variability. If this was 5 and 6, it'd be 30, but it's not, so it's a little bit nastier. Well, on the other side, we'll have x plus 6, x minus 2, and all of that fun stuff. So, multiplying the x minus 6, or x plus 6, excuse me, that cancels there. X minus 2 cancels there. Both cancel over there. And what we'll be left with is 3 times x, not plus, excuse me, minus 2 plus 1, I'll leave it there just for sure, times x plus 6, and that will just be left with 4. So now we can multiply things in and start rearranging to get to where we want to be, just remembering for ourselves to be sure here that, let me actually write that down over there, I should have wrote that earlier. With this rational equation, there are a couple of things that we don't want, and that make it so that these are not precisely the same. We don't want x to be negative 6 or 2, and to get it over to that, our LCM was actually the quadratic term. Anyway, getting back to our math, we can proceed because this guy's actually pretty linear. The semi-equivalent piece. That'll be a 3x, multiply 3 times negative 2, you get negative 6. Well, that's just x plus 6 and 4. And, well, that's pretty convenient. We don't even need to pile these guys over. They just kill each other. Plus 6 minus 6, 3x plus x is 4x, and I'll just throw that equality over here to stay in line, equals 4. Divide both sides by 4, and you will get x is equal to 1. Not the very prettiest process, I have to admit, but you do get that as your answer. And if you wanted to give that as a solution set, you would have that the solution set here is the loneliest number, all on its own, x equals 1. And yes, you should check this for yourself, but I will leave that to you like I did with the last one, because I'm a little bit lazy with writing these things out, but you should be able to see what you need to in this case. And if you want to classify this as conditional, inconsistent, or an identity, because this is only true once, when x is equal to 1, this is conditional. But I digress. The last thing we're going to look at here is another application.